All right, let's get this show on the road. So, 4.3 is about representations of reactions. So this is the physical part. You want to use your past experiences, thinking about chemical reactions, particulate drawing. And this will incorporate these over the rest of the course, so they come up a lot, including the solubility. So you have the idea of phase changes. You have a very simple thing melting, being able to show it as a solid and as a gas with lots of spaces in between. Precipitates. Now again, I kind of color-coded the sodium and the chlorines, so you can see how they're aqueous, spread about, all kind of mixed, and equal in number as well, 5 to 5. Again, I've seen things to say, at least if you have one of them to one of them, you're good. But I just showed that, 5 to 5, so the ratios are adequate. You could have the ideas of sizes being different as the ions. Again, they would probably model that way, not you. Water's often emitted, so you don't see any water molecules anywhere. Again, you have the silver and the nitrate, again showing around, but of course you could have different sizes, like different spheres being bigger or smaller, or something nitrate, you have something with 1 with 3 oxygens all the way around it. And again, you can see the solid. I put the silver chloride matching my colors as a solid, while the rest would be floating around in the, let's say, beaker. So making sure that you represent this. Now, color is not going to be a way that they're going to do this because it is a black and white test and you only really have a pencil. But I'm trying to help you visualize this, that a solid being clumped together, because again, any reader is going to have to interpret this. So you want to make sure it's as clear as possible to any person who reads this. A gas being produced, right? You have a solid, we've got some water molecules. You should understand by being aqueous that this is going to make a aqueous solution. And so you can see I've got the OHs in here, but they're separate because you should know that this dissolves in water. And I've got the sodium ions floating around. While the gases are out of the solution, I drew this little line just to indicate that that is a solution of some sort, and the gases would, of course, freely floating. You got your H2s, things that are all the same ratios as they should be. Again, representations of what you have. Something like dissolving. I've got a structure here, best represented, or best as I could represent it, and they become separate, become aqueous from each other. Now, in things of dissolving and being aqueous, they often will show water, and I just drew this simply as kind of an angled area to where your oxygen, you need to understand that being negatively charged, hydrogen's being positively charged. So around the positive ion, you should have the negative water components pointing towards it, and the negative ion would have the positive pointing towards it. Again, you might be given this, you might have to explain this, you might have to visualize it. You could even be given something wrong and talk about what's wrong with it. That's always a possibility. So, importance. This comes with the FRQ for sure, and it can be seen on multiple choice questions as too. Use whatever setup they provide. If they give you ions with charges, you do the same. They give you dots representing even more than a singular element, go with it. If they do space filling models, to where they're bigger or smaller, go with it. Rarely do they have you want to draw something without giving anything before, because then it can be open to interpretation, right? You saw my images. I gave you my interpretation of kind of how I would draw it. And so if you have a reader looking at all these different random types of drawings, that makes it really hard for the reader to grade it accurately, and the same for everybody. Be careful about representing the amounts, making sure if it's a 1-to-1 or 1-to-2 ratio, you show that in your image. States of matter, illustrating the idea of solids being a chunk, liquids being kind of low and to the bottom, gases may be filling their whole container. They're looking for that. And again, any other kind of information, a chemical reaction, image, representations given, use what they give you, because they will give you enough. You just have to interpret and make it your own. All right, let me know what kind of questions you have. Catch you on the flip side.